Hello friends, I am Sudhanva, and in the first video you heard the voice of my friend Yogesh, which talked about the very first method of Vedic maths as far as multiplication is concerned, which is Nikhilam. Nikhilam method has its shortcomings, and thus this video I will present you the modified Nikhilam method known as ANURUPYEN in Sanskrit, and which is in simple word you can say change of base. So without wasting a time, we will start with example 1, which is 57 multiplied by 51. Now both these numbers are neither close to 10 nor to 100, and therefore we will do change of base, which is 100 divided by 2 transforms to 50. So all that rules which applies to the first method, also applies here. So 57 has 7 extra to 50, so we will write 7 on the right side and subsequently 1, and thus on the right side we do the multiplication of 7 and 1, which is 7. But as the original base 100 has 2 zeros, the right side must contain 2 digits, so we have a 0 before the 7. So on the left side we can perform either one transformation, like 51 plus 7 or 57 plus 1, which is 58. But the difference is we have to divide this 58 now by 2, because we divided 100 by 2 to get 50, and which is we will give you 29, and thus answer for the multiplication is 2907. So let's get some little different example. So in this we will take 43 and 46 as numbers. So same thing, the base is again 50, but these two numbers are deficit to 50, so we have to write bar notation, 7 bar for 43 and 4 bar for 46. So as usual, multiplication on the right part is 28, and cross addition or subtraction, which is 43 minus 4 is equal to 46 minus 7, which is nothing but 39. But again, the transformation of division by 2 must be performed on the left side to get the right answer. So 39 by 2 is actually 19.5 precisely, but here first of all ignore the decimal sign and add the 5 and 2, so that gives us 1978. This was a little variation, so I chose this problem. So now we can move on to the next example. In which we will take 3-digit numbers. So let's take 197 and 213. Now obviously we are transforming the base 100 into 200 by multiplying it by 2. So guess what? We have to multiply 2 to the left part of the answer. So deficit of 3 for 197, and 13 exists to 200 for 213. So on the right side, the multiplication leads to 39 bar, and 213 minus 3 will be 210. Now remember, multiplication by 2 to the left part of the answer must be performed prior to writing the final answer. So 2110 multiplied by 2, 420, 39 bar. Now the bar notation is finally converted into usual form, so which is equal to 41961. And I hope you understand this example clearly. So the next example, let's take numbers close to 500. Let's choose numbers 417 and 498. Now our original base for this example is 1000, which we are going to divide by 2 to get 500 as our modified base. Now 417 has a deficit of 83, so we will write 83 bar to the right of 417, and similarly 2 bar to the right of 490. As usual, multiplication on the right part, 83 into 2, both are negative numbers, so product will be positive, 166, and 417 minus 2 is 415, which is easier to perform than 498 minus 83. So now we must first divide the 415 by 2, because we chose 500 as our base from the original 1000, so which is 207.5. Again, remember, decimal sign we are going to ignore, and that 1 from the right side will be added with the 5, and ignoring the decimal sign, you have to write the final answer 20766 and 6. Look friends, this was not the easiest of the example, but we did it pretty easily. So now let's take a little more difficult example, which is a 4-digit numbers. Let's choose the numbers 2107 and 2113. Now, by the time you must guess that the base for this example would be transformed to 2000 from 1000, sorry. So now, carefully listen to me. 2107 has 107 extra to 2000, and similarly 2113 has 113 in extra of 2000. So this is a little more difficult, you can say. Now first we will process on the left side, that is 2113 plus 107 or 2107 plus 113, which we will get as 2220. 2220. But again, 1000 into 2 is 2000, therefore this must be multiplied by 2, which is 4440. And on the right side we have to perform again the same thing on the number 107 and 113. In this case we will take base 100 and do it very easily. Well, if you practice enough, you can do it pretty much orally after you have solved ample problems. Actually, this software is not easy to use. So 7 extra 200 and 13 extra 200. So multiplication on the right part leads to 91, which is same as the number of zeros in 100, so we need not worry about that. And on to the left part we write 113 plus 7, which is 120. And this is very much final answer as far as this multiplication is concerned. So we'll write it as a right part of the previous result. So let us write 12091. But obviously this is not gonna be a right answer, as it has more than 3 digits, which are the number of zeros in the 1000, the original base. So 091, let's keep it apart and add 12 to the left part, which is 40 plus 12 will lead to 52. I'm sorry. So this is 19025544. So look, this wasn't the easiest of the example to solve. And one important thing you should notice is that computational memory required is very low in these methods. So now let's take one simple example so that you can assess whether you understood whatever been taught till now. Pause the video and try to solve it on your own. One final example based on this method, simple example of 2 by 2 numbers we are going to take. So let's take example having 100 as a base, 78 multiplied by 89. Pause the video and try to solve on your own so that you can understand whether you have understood the concept. Now actually we are not gonna take 100 as a base in this example. You try to solve it using 100 as a base, but we will solve it by transforming 10 into 80 by multiplying by 8. Obviously this is very flexible method which allows us to choose whatever base we want. So we will take 80 as a base without any problem. So 2 bar, as a 2 is a deficit of 78 to 80 and 89 has 9 in excess of 80. So 18 bar will be on the right part and 78 plus 9 will be 87. But we have to multiply it by 8, as we multiplied 10 by 8 to transform the base into 80. So it is 8 into 7 is 56, so it will get into 696. 8 bar. Now in the first video you were familiar to how to convert this number back to the usual form, but one thing you must notice prior to that is that the number of digits on the right side, which is more than 1, as the number of zeros in 10 is only 1, there should be only one digit on the right side. So that 491 bar should be taken to the left side, so 6 minus 1 will lead to 5 and 8 bar. So now it's pretty easy to convert this. 8 will turn into 2, and bar 1 from the next number, you will finally get 6942 as the final result. And friends, this concludes this video, and I hope you understood